Select the properties of the SN1 reaction mechanism. So they give us all these different properties. A, stereospecific, so this means 100% inversion of configuration at the reaction site. B, not stereospecific. C, bimolecular at rate determining step. D, unimolecular at rate determining step. E, rate is governed by steric effects. Or F, rate is governed by the stability of the carbocation that is formed. Okay, so first I'll just show a typical SN1 reaction, which is also known as a nucleophilic substitution reaction. So typically this takes place in 2 steps. So first we have, let's just say R binded with L. So this is our substrate. And for the first part of the mechanism, we have L, which is our leaving group. Which is removed. And we're left with R plus L minus. Okay, so I'll also just write down that R plus is considered as our carbocation. So this just means like a positively charged carbon group. And L is our leaving group. Okay, so step 2 of this reaction is when we have our carbocation that reacts with a nucleophile that can be like a halide. So this is our nucleophile. Okay, so the negative charge comes in to neutralize the positive charge of our carbocation. And then we are left with our product. Okay, so now let's go over all of the options that they give us. So is this reaction stereospecific, where 100% of the conversion, 100% inversion of configuration at the reaction site, or is it not stereospecific? So the answer is that it's B. So it is not stereospecific. And the reason for this is because our nucleophile can attack from any side. So for the next section, is it bimolecular at a rate determining step or unimolecular at a rate determining step? So the answer is D. It is unimolecular. And this is because our reaction is only first order. And lastly, is the rate governed by steric effects, or is the rate governed by the stability of the carbocation that is formed? So the answer is F. The rate is governed by the stability of the carbocation that is formed. Okay, so I'll kind of explain this. Step 2 would be considered our rate determining step. So as you can guess, that means that it's the step where the rate is determined by. So in this case, if our carbocation, which is R+, is stable, then the reaction is a slow reaction. Well, it would be slower because the nucleophile wouldn't want to attack something that is stable. So that reaction that forms our product would be slower. But if the carbocation was unstable, then the reaction would take place faster and make us more product. So typically the carbocation is most of the time stable, unless it was more stable with like another group attached to it. And the junior tutor said that the given mechanism is not stereospecific, since the carbocation that is formed gives a planar structure which allows for attack from either side. It is also unimolecular because the rate determining step, which is the formation of the carbocation, does not need help from the nucleophile. Steric effects do not play any specific function because the carbocation is planar, and the stable carbocation disperses the positive charge throughout the molecule. So they had B, D, and F. So this solution is correct.